Hey. There we go. Welcome to Thinking in TypeScript, also known as Godfrey Races Against the Clock to cover 63 slides in 25 minutes. Here we go. Hello, I'm Godfrey. You can find me on the internet as Chunking Code. I work at a small company called Tilda. And yep, you already saw that this morning. You already heard that. We are a tiny company, but somehow we end up sending a quarter of team speaking at the same conference. And indeed, we're not allowed to fly on the same plane going home. You already saw this. We make a product called Skylight. Buddy already told you about that. The only thing I want to add is if you have or you know of any open source Rails apps, it's free, so sign up. We also make an open source framework called Ember. If you haven't heard of it or if it's been a while since you checked it out, I have good news for you. We have a new pretty substantial release coming out called Octane that significantly revamps the programming model to be easier and more productive than ever. So there's a great new tutorial too. I might be biased because Vadi and I worked on it in the last couple of weeks. So if you haven't seen it yet, even if you have no intention of using Ember, go check it out. I will love your feedback. Find me on Twitter. Find me outside after. All right. So with that out of the way, let's talk about TypeScript. So how many of you are already familiar with TypeScript here? OK, there are like 20 of you. And the rest have not heard of TypeScript, which is great because this talk is for you. This is not this talk. It's not really. It's not a paid promotion for TypeScript, right? So like I understand for many reasons you might not be able to adopt TypeScript in your company right now, and maybe you don't like it or whatever. But my goal with this talk is, after this talk, A, hopefully you would appreciate it more, but B, even if you don't use TypeScript or you can't use TypeScript or you're not planning to use TypeScript, I hope you will still be able to take some lessons away back to work that could change the way you read JavaScript, you write JavaScript, and you do code reviews and stuff like that. So, for those of you who have not seen TypeScript, this section is for you. This is not meant to be a complete introduction to TypeScript, but just enough that you can follow the rest of the presentation, hopefully. So here we go. Now, let's imagine you're debugging an issue that came up at work, and you came across this function. This is just a regular JavaScript function right now, no TypeScript involved yet. So maybe this is a function you found inside some third-party library, or maybe you wrote this code 5 years ago when you were half asleep. Either way, we have no idea what this function does. So just looking at the function signature, what can we learn about this function? Unfortunately, not a lot, really. We know the function is called measure, and we know that it takes an argument called target. So presumably, if English means anything, hopefully it has to do with measuring something related to that target parameter, whatever it is. It also takes a second parameter called options. So again, presumably, if we can trust English, hopefully it allows you to configure or change some aspect about how this function works. But as far as what is it measuring, is it measuring time? Is it measuring dimensions? Is it measuring distance? Don't know. Also, what does it do after measuring the thing? Does it return anything? No idea. What options does it accept? We don't know. So unfortunately, that's probably all we can figure out by looking at just the signature for now. So let's just keep reading. So OK, on to the first line. We see that the function here is checking if the target parameter is a string. So that tells us a little bit, not a lot, but we know that the target parameter can sometimes be expected to be a string. But we also know that the target is not always a string. Otherwise, it will be pointless to check this in a conditional. So we know target, sometimes a string. That's about it. So let's keep going. Now, next, we see that the function is passing the target string into document.querySelector. We happen to know that this is an API that exists in the browser that takes a CSS selector and find the element in the DOM that matches that CSS selector and return a single element. So we know that when the target parameter is a string, it is probably expected to be a valid CSS selector. Otherwise, document.query selector will throw and everything blows up. So, and furthermore, we know that when target is a CSS selector string, the function reassigns the target parameter to the element referenced by that selector. So if we were to make an educated guess here, you probably think that the function probably expects the target parameter to be either an element or a CSS selector. Again, it looks like the conditional statement here is trying to normalize the difference between the two things so that the rest of the function can just assume that they're always dealing with an HTML element. So like from now on, probably the target variable holds an HTML element. That's what we know so far from reading 3 lines of the function. All right, let's keep going. So next, the function accesses the offset width and offset height property of the target variable, whatever that is. This seems to confirm our guess earlier because these properties happen to be properties that are available on HTML elements in the DOM. So we are probably correct in thinking that target is an element. And since the function is called measure, and we know that target is an HTML element, and we're looking at offset width and offset height here, an educated guess would be that this function is measuring the dimension of a DOM element in the browser. But let's keep reading. So the next line in the function checks for options.margin. So this tells us a little bit more. For starter, options is probably expected to be an object. Otherwise, when you use the dot notation, it will probably not do what you expect. So that's good to know. And also, whatever this object is, it has a property on it called margin that is probably a Boolean, if I have to guess. And inside this code branch, what is it doing? The function passes the target, which our best guess is an HTML element at this point, to the getComputedStyle browser API. And with that, I think we can be quite confident that the target is actually an HTML element, because if you look at the documentation on MDN, getComputedStyle takes an element. If you pass it anything else, it will raise a runtime error. So if this code can be trusted, it's probably dealing with an HTML element. We can be quite sure about that at this point. And finally, we see that we are adding the margins, the CSS margins, to the width and height variable. So it seems like when you're setting options on the margin to true, or at least a true v value, this function is adding the margin to those. And we see that it's calling parse float, so we also know that it's probably a number. And so, finally, we have reached the end. At this point, hopefully we finally understood what this function is doing. The function job is to measure the dimension of an HTML element on the page. And you can either pass a CSS selector or an HTML element directly, but and also optionally, you can ask the function to include the element's margins in its measurement. But either way, the function will always return an object with a width and a height property containing numeric values about the element's dimension. So that was that. And wow, that was a lot of work. It took 5 minutes to read this one function. It's not even a very long or very complicated function. So clearly, what we need here is some good documentation. But how are we supposed to document these things? Well, that's where TypeScript comes in. A lot of time, people refer to TypeScript as a language, which is not technically wrong, but I think it made TypeScript sound a lot more scary than it actually is. I find it more helpful to think of TypeScript as a tool that you can run on your existing code base, similar to a linter, like ESLint maybe. at the end of the day, you're not learning a new programming language. You are just programming in the same JavaScript that you already know. And all you're doing is sprinkle in some extra documentation or some extra annotations about the intention of the code, which has the immediate benefit of making it easier for the human reader to understand what your code is trying to do. But also, it just so happens that the TypeScript compiler can understand those annotations and give you some additional benefits, which let's look at how that works in practice right now. So for some of you, this might be your very first line of TypeScript. This is how you declare a variable in TypeScript. As you can see, it's very similar to the JavaScript that you're already used to. The only difference is that we are explicitly stating our intention that this variable stores a number. So the TypeScript compiler can use this annotation to help you avoid certain kind of mistakes. So if you assign a number to a variable, all is well. But if you try to assign anything other than a number, you'll get a helpful error message from the compiler or maybe even inline in your editor. You can also tell TypeScript that a variable can contain more than one type of value. So here we declared a variable called target that can contain either a string or an HTML element. So again, if you do what you said you're going to do, all is well. But if you break your own rules, TypeScript is not going to let you get away with it. So that is that. But of course, most of the time, you're not just working with primitive values like strings and booleans and numbers. So TypeScript have you cover as well. TypeScript other features that let you build out more complex types. For example, this is how you would document your intention that this variable should contain either contain an object literal with a single Boolean property called margin. So this is how it is in practice. If you TypeScript is going to use that information to make sure you're doing exactly what you said you're going to do and prevent you from doing things that you shouldn't be doing. And one last thing, the colon syntax is not unique to variable declaration. Basically, TypeScript consistently uses this colon type syntax everywhere where a type could be necessary. So for example, here we're using the same syntax to annotate a function's parameter and its return type. And everything else is just standard JavaScript. With that little bit of information, TypeScript is now able to catch all sorts of mistakes for you. And it will make sure that you're calling this function with the right kind of arguments and the right number of arguments and so on. So, and that's hopefully, possibly, the shortest introduction to TypeScript and putting everything we learned so far together. This is how we can annotate the measure function that we saw earlier. And this time, if we just look at the function signature alone, suddenly we know a lot more about what this function is doing without having to read any of its source code, right? For starter, we know that the target parameter is either a string or an HTML element. An options parameter has a margin Boolean property on it, and we know that it returns an object with a width and a height on it. Now, of course, you will still want to supplement this with some textual documentation, but it would have, even without that, it would have been super helpful to have this information 5 minutes ago. In fact, the function signature was the only place that we actually added any TypeScript. The body of the function is exactly the same JavaScript that we saw earlier, and using just the information we sprinkled in the in the function signature position, TypeScript can figure out everything else for us. For example, in your editor, if you hover over the width variable, TypeScript can tell you that it knows that it's supposed to be a number, even though we didn't explicitly annotate its type. I don't have time to get into the detailed explanation of how this works, but for now, you can take my word for it, hopefully. So, OK. Now that we've learned some basic TypeScript, we can move on to the second part of the talk. And let's talk about every JavaScript developer's favorite feature, now and undefined. At Tilde, one of the things I worked on is a rendering engine called Glimmer, which is used by Ember to render components into the DOM. We started using TypeScript for that project in 2015, around TypeScript version 1.5 or so. At the time, TypeScript assumed that every type is optional, meaning that you can always assign null and undefined to every variable, function, argument, return type, and so on. So here, you can see that we have a variable that's typed as a number, and even though TypeScript will stop us from assigning a string or a Boolean to it, it will happily let us assign null and undefined without any errors. So you may be wondering, what's the big deal? Why does this matter? Well, let's look at how this can cause problems in the real world. At the top, we have a pretty simple function here. It takes an array of strings and a regular expression as an argument, and it returns the first string in the array that matches the given pattern. And below it is how we expect this function to be used. Unfortunately, because TypeScript 1 allows null and undefined to be assigned anywhere, it also allows these clearly invalid invocations of the function. And if you're thinking, come on, this is nonsense, who write code like that? Well, hold that thought, and let's see how this may end up happening in your code without you realizing it. So let's build a new function on top of our very simple first match function. Our second function is called ratenames. It takes an array of names and rank them against each other and print the best one to the console. By default, the casing of names doesn't matter. It can be spelled in all lowercase if you can't be bothered to reach for the shift key, or if you're a super angry person, you can spell them in all caps if you want. The function ignores these differences by first transforming all the names into lowercase, so it doesn't have to care. So, seems good. Then the function finds the first name in the array that ends with VE. So for some reason, this was the criteria that was chosen for what makes a name good. Don't ask me, I just fix the code, I don't write them. Finally, once it found a suitably good name, it will print it to the console with some additional formatting. So putting everything together, this is what it does when it's working correctly, right? So if you do rate names, Dave, it will say Dave is the best name. If you pass Eve, it will tell you Eve is the best name, and if you have more than one, it will give you the first one. So, so far so good, but spoiler alert, there were multiple bugs in that code. I don't know if you caught it. If you caught it, good for you. If you didn't caught it, no problem. We'll come back to this soon enough, and in fact, TypeScript is going to review to us what the bugs were. All right, so that was 2015 and TypeScript 1. Fast forward 1 year, in 2016, Microsoft released TypeScript 2.0, and with that, they added a new mode that you can turn on called strict null checks. In this mode, TypeScript no longer allows null and undefined to be assigned willy-nilly. Instead, you must explicitly annotate the places where you want to allow null and undefined to be assigned. So this is how it works. Once again, we have a variable called I here with the number type. And if we try to use this variable before assigning a value to it, TypeScript can now give us an error because at this point, its value would have been undefined, which is in fact not a number. And of course, TypeScript still doesn't allow us to assign strings and booleans just as before, but also it now stops us from assigning undefined and null here also. If you do want to allow undefined, though, no worries. You can just explicitly annotate your type, just like you would with any other types like boolean or string or something like that. However, note that TypeScript do not, in fact, consider null and undefined to be interchangeable. If you say this variable contains either a number or undefined, TypeScript is not going to let you assign null to it. And if you really, really want all three of them, no problem. You just have to be a little bit more explicit about that. OK, so that's cool, but why does any of that matter? Well, for a starter, all the invalid invocations that we saw earlier are now caught by TypeScript. But again, that's great, but who writes code like that, right? What else did it catch? Well, guess what? With strict null check mode turned on, TypeScript now found an error in a apparently very simple one-liner function. What could that be? As it turns out, we promised to TypeScript that this function is supposed to return a string, but TypeScript is now thinking that we're actually returning either a string or sometimes undefined here. Why is that? If we ignore the type error for a second and we hover over the find method, we can now see the problem. As it turns out, TypeScript is now aware that the arrayfine method can sometimes return undefined, and the documentation there tells you exactly why that could happen. If it couldn't find any elements in the array that matches the criteria, return undefined. And because we didn't do anything special to handle that case, we're essentially just propagating the possibility of an undefined value to our caller. In this case, there's actually nothing wrong with returning undefined here per se, but TypeScript just wanted us to be honest about what's happening. So we can fix that type error by explicitly saying that this function can also possibly return undefined. So with that, the type error is gone and everything is great. So let's look at how this new mode affected everything else in the code. Now, with strict now checks enabled, TypeScript actually found 2 more errors in our ratename function. So here's the first one. As it turns out, the problem is that we only initialize the candidates variable when the ignore case flag is set. Just so happens that the ignore case is set to true by default, so maybe your test didn't catch it, but like if you actually set it to false, you can follow the code and see that the variable was never initialized, so when we pass it to first match, that could possibly be undefined. So TypeScript is not going to let us get away with that anymore. And so to fix the problem, we can make sure we always initialize the candidates variable before using it, regardless of whether the ignore case flag is set or not. We can do that in the same place where we declare the variable in the first place. And with that, this type error is gone. The second error comes in the place where we try to call bestName.slice. Since we now correctly annotated our first match function as returning either a string or undefined, TypeScript has caught another bug for us. Turns out it's totally possible that none of the names we pass actually ends in VE, so bestName could totally be undefined as well. Since we also didn't do anything special to handle this case, bestName.slice could blow up at runtime if that turned out to be undefined. And so fixing that is easy enough. We just have to handle that case separately. And with that, TypeScript is happy, and your customers are happy, and everyone is happy. So the moral of the story is undefined can be pretty sneaky and dangerous. And if you're using TypeScript, you should definitely try to make sure you have strict now checks enabled. But for those of you who are not using TypeScript yet, I hope the walkthrough we did here can show you what it is like to have TypeScript by your side, nudging you away from the subtle bugs that could break your code in unexpected ways. But more importantly, even if you're not ready to adopt TypeScript anytime soon, by learning how the TypeScript compiler reasons about your code, hopefully you can try to apply the same kind of analysis in your head when you're reading code or when you're doing code review. And speaking of which, let's use the last 2 minutes to take a look at a few more ways that undefined can sneak into your code without you noticing if you're not using TypeScript. So the first one is bare returns. Specifically, if you use the return keyword without providing a value, essentially you're returning undefined. And that's especially bad when your functions sometimes return a value and sometimes not, because your caller might not be expecting that. Like it would work most of the time, but occasionally undefined would slip through there in your early return, and that could be unexpected, and it could break your caller and cause us a problem down the road. If this is something you want to do, you want to make sure that you clearly documented and communicated that to people calling your function so that they can be defensive against that. The second thing is basically the flip side of that. Here, instead of an early return, we flipped it around and we just guard it again. Like we only return a value when first and last name are both truthy. But that's basically the same problem because if you reach the end of the function without returning, JavaScript would just return undefined for you. So basically the same problem, but more subtle. The next one is property access. Unfortunately, when you access a property that doesn't exist, JavaScript will happily not error and just give you an undefined. So If you're not using TypeScript, you just have to be extra careful about these and make sure you didn't make any typos in your property access. Next one, missing function arguments. The problem is that even if you declared your function as taking 2 parameters, 3 parameters, doesn't matter. JavaScript will happily let you call it with fewer than that. And if you do, it will fill the rest with undefined. And so that could be a problem. So when you're not using TypeScript, you should make sure your arguments and your parameters matches up as expected. Finally, the last one is void functions, which is basically just functions that doesn't return anything. So again, if you're working with TypeScript, be extra careful that the functions you're calling are returning what you think they're returning. So with that, my 25 minutes is up, and hopefully it will be helpful. Thank you very much.